two types of forces: contact forces and non-contact forces. Gravitational force is a non-contact force. Actually, force is an interaction. So here bodies are not in contact. They are not in physical contact. If bodies are in physical contact, then forces are known as contact forces. To explain non-contact forces, we can use the field concept. Now in this video, let us see gravitational field and intensity of the gravitational field. The force between these two masses is given by Newton's universal law of gravitation. Now two masses m1 and m2. Force experienced by second mass because of the first mass is given by this relation minus gm1 m2 by r square r cap, where r cap is a unit vector from first mass to second mass. Force experienced by the second mass because of the first mass is directed towards the first mass. Now let us see what is in gravitational field. Now surrounding a mass, there is a region in which another mass will experience a force. For example, Earth is in the gravitational field of Sun. Earth is several kilometers away from Sun, even then it is influenced. So this can be explained by field concept. Gravitational field is the space around a mass in which its influence is experienced. So here Earth is in the gravitational field of Sun. Then intensity of the gravitational field is different at different points. The intensity of the gravitational field at a point is defined as the force experienced by unit mass. Now this is the force experienced by the mass m2, unit mass. So we have to divide this by m2, then we will get the force experienced by unit mass. So this is the force experienced by a mass of m2 kilogram. You divide by m2, then you will get the force experienced by unit mass. So intensity is measured by the force experienced by unit mass. Force is measured in Newton, mass is measured in kilogram. So intensity is Newton per kilogram. Now after dividing this by m2, so you will get minus gm1 by r square r cap. This, when we divide by m2, this m2 will get cancelled. So this is the intensity at this point because of the mass m1. So intensity depends on the mass m1. It will not depend on the mass m2 because it's a force experienced by unit mass. So m2 is assumed to be 1 now. The force experienced by unit mass is known as intensity. Then in general we can write intensity. So instead of this m1 we can write m mass m. So for this m1 we can write, so in general the intensity at a point which is at a distance r is given by this relation minus gm by r square r cap. R cap is a unit vector from the point between and the mass r cap. This is directed towards this is r cap is from first the mass to the point in consideration. Then intensity is towards the mass. So this minus r cap. Now here there is a mass capital M and intensity at this point is given by this relation. So force experienced by this mass is given by this F vector is equal to m times E, where E is the intensity. Intensity is the force per unit mass. So the mass kept is m. So this is the force. Then according to Newton's second law, force is mass into acceleration. From these two relations we can write intensity is equivalent to acceleration. These two are two separate quantities. Intensity depends on the source and acceleration is the effect produced by this mass. Intensity is measured in Newton per kilogram. Acceleration is measured in meter per second square. So these two are two separate quantities. Now when we move away, intensity is going on decreasing. Intensity near the mass is more. So this magnitude of the intensity, this negative sign is to show the direction. So intensity is directed towards the mass. So this is the expression for intensity of the gravitational field. So intensity depends on the mass and the distance. Then now let us see superposition principle. Here there are so many masses, m1, m2, m3, etc. up to mn. Now we have to consider a point P. We want the intensity at a point P. So unit vector along this direction is r1 cap, along this r2 cap, and finally this is rn cap. So we have to find the intensity at this point due to individual masses. Then we have to find out the vector sum. That is called the superposition principle. Intensity at a point due to a number of masses is the vector sum of the intensity due to individual masses. Now total intensity is E1 vector plus E2 vector, etc. up to En vector. Now intensity at this point, because of the mass m1, which is at a distance r1, is given by this minus g instead of m1. Distance is r1 square, r1 cap. Similarly, second mass. Then this is the total intensity. Now this can be written as the summation sigma. Then negative sign is common, written outside. Then m1 r1, so m2 r2. So we can write mi ri square, where I changes from 1 to n. Here 1 to n.